Hello, I'm Leo. I'm from Sismo, and today I will talk to you about ZK Attestations and an applied use case, how we can get your app without doxing your users. So in the first step, we are going to see the Sismo Protocol theory, how it works, and in the second part, we are going to see a particular use case we did last week, so Ethereum power users ZK badge. So yeah, Sysmo is a modular attestation protocol focused on decentralization, privacy, and usability. So first, what is an attestation? So it's a certificate that proves a fact. So it has an owner, a value, a recorder or an issuer, a timestamp, and some extra data. So attestations are bundled in collections. So ZK attestations are just attestation that proves a fact with zero knowledge, so without revealing anything about the fact, how it's proves. So basically, to prove a fact, you have three possibilities. You can prove it publicly, you can prove it through a third party, or you can prove it using ZKP, and we are using ZKP at Sismo. So what we are doing is that we are issuing attestation from claims about group membership. So here you can see what is an account. So an account, it's an account identifier and an account value. And the groups of accounts is a set of accounts. So here you have a very simple example with an extract from the Ethereum power users group of accounts. So we are proving membership of a source account into a group of accounts, and we send this attestation, so the owner of the attestation will be on a destination account. For example, you can use your private addresses as a source account, and you can use a public address as a destination account. So for instance, if you want to prove that you did a lot of transactions on Ethereum, or you have more than I don't know, 1,000 Ethereum on your private addresses, you can put this attestation on your public address. So with ZK attestation, there is no link between the source account and the destination account. This is what is interesting about ZK attestation. So in the Sismo protocol, we have these attestations that are stored on an attestation registry. And we have some attesters that are like issuer that can write in this attestation registry. Also, you have badge contract that is a NFT and that read directly to the attestations registry. So we can split in three parts. So we have the left part, which is how attestations are verified and built, how attestations are stored in the attestation registry, and how they are consumed. Everybody is welcome to create new attesters and new badges contracts because it's created to be very, very modular. So we're going to see how attestations are issued with attesters in the next part, and how badges, what are badges and what can be done using attestations. So yeah, an attester verify a user request of a claim of group membership. It will then build the attestation and record the attestation on the attestations registry. So when you have a ZK attester, it's just that the verification of the user request is done using zero knowledge proof. So the attesters are just attesters that issue the key attestations. So what is zero knowledge proof? Zero knowledge proof is a new cryptographic primitive that allows a prover to prove something to a verifier with three main properties. The completeness, that means that an honest verifier will be convinced with a very high probability from an honest prover. The soundness, that means no malicious prover can fake statements about a proof to an honest verifier. And the zero knowledge one, that means the verifier don't know anything about what is inside the proof except the statement, so if it's true or false. So I like to present it as you can execute a computation without cheating in the computation, and the content of this computation remains private. So the prover is making the proof, it sends the proof to the verifier, and the verifier will say if it's true or false. So for instance, if we know a secret, hash this secret, you can prove to the verifier that you know the secret with, which was hashed without revealing the secret. And to be more precise with Circum, so circuit compiler from ident3, you can make your proof in with JavaScript, and you can send this proof to a smart contract verifier. So at Sismo, we developed our first ZK attesters, the first attester we developed for the protocol that used a circuit we created, which is named Hydra S1. And it allowed to issue zero knowledge attestation based on membership. So the prover will verify that the user owns a source account. So it will also verify that the user owns the destination account. It will verify that the account is inside a group of accounts with a Merkle proof. It will verify the account as an associated value, as we saw in the last slide. And the user will generate a ticket that is namely named nullifier, and that will be stored on chain to avoid double spending, to avoid to create multiple attestation for the same source accounts. So if we come back to the attestations registry and you know our different smart contracts, we saw the left part that was you know the attesters, how the attester verify a proof and how they write the attestation on the attestation registry, and now we will see how the badge is made on top of the attestations registry. So the badge is a stateless contract that read on top of the attestation registry. It read the balance of the contract directly read to the attestation registry contract. So it's stateless, and it allows to be compatible with the 1155 standards. That means you will have an NFT associated with your attestations. And with this attestation, you can do a lot of different things for consumers. For instance, you can use a snapshot, guild, lens, on-chain, etc. So now, maybe you have some questions about the first part.
To make these proofs, you're putting this in a hash tree, like a Poseidon hashes, I'm assuming. Do you also, like, who's constructing this, and is this part of the proof? Like, is there some known signature from your side that you're signing each leaf with and prove that, or? Yeah,
so when we create the group of accounts, this is formatted as a Merkle tree, and it's all the Merkle tree is downloaded on the browser of the user, and the user will generate its own Merkle proof inside this Merkle tree for privacy reasons. And for our first attester, we are the issuer of the attestations. So Sysmo is the issuer of of these attestations, and we are constructing our own Merkle tree for this attester.
Hi. I wanted to ask, when you say that in the prover, the user has to verify the ownership of the source account and the destination account, which type of signature, if you use signature verification, use to prove that?
We use an off-chain commitment scheme. That means that So it's really similar to semaphore, but with an off-chain part. That means that you will send a proof of ownership of your account with it's an ECDSA signature. You send it into an off-chain commitment. You will create a whole commitment, an anonymity set which is off-chain and hidden. And thanks to that, we can verify the delegated proof of ownership of this off-chain commitment inside the zero knowledge. So you just have to do it once, and after that, it will be you will be able to use your source account for each different type of attestations.
Okay, clear. So the second question is, I guess you are not using directly the ACDSA signature inside the prover because it's too much to computation, right?
Yeah.
Okay, cool.
So yeah, to verify a proof of ownership and to generate a nullifier, the really good way to do it is to use directly the private key of the user and to verify the signature, the ECDSA signature inside the zero knowledge, and to use the private key as a source nullifier to avoid double spending. So this is really how it should be done, but there is a very huge limitation for now. There is two limitations. The first one is that verify ECDSA signature inside zero knowledge is very heavy in terms of computation. It's around 1 million constraints, so around 1 minute to compute in a browser. And the other problem is that you can't access to the private key of your users, so you can't use it as a nullifier. So the scheme we did use an off-chain commitment where the user creates a secret. He hashes this secret in his browser in the front end, and he will send this commitment in the off-chain commitment scheme. He will then prove that he owns this commitment through the secret he previously hashed, and this secret will be part of the source nullifier.
Thank you.
Okay, so we are going to see a practical, concrete example of power user ZK badge we did last week. So here are what we want to do. We want to generate a group of accounts from the top transaction. So it was the top 50,000 users that did the most transaction per year from 2016 to 2021, and we merged them in a huge group of accounts. We joined these small groups in a huge group of accounts. So thanks to that, we then need to provide a badge image and some metadata for the NFT. And in the third part, it's how we are going to integrate it with tools. So Guild collaborated to do a gated channel and a snapshot to vote on the evolution of the group. The idea was to let users vote privately, so through their ZK attestation and the key badge, on how they are going to let the group change in the future. So if we integrate new user, how we are going to integrate them and stuff like that. So as we need a lot of infrastructure to create the group of accounts and the Merkle trees, and to provide these Merkle trees to the user in the front end, we created a whole repository and project that is called Sismo Data Sources, and it helps to provide the infrastructure to generate some group of accounts with some scalable infrastructure on AWS to put those data on a public API. So for now it's only an S3, but it can be IPFS very easily. And then also under attestation collection, so the link between the groups that you made available for an attester, that auto-send the transactions for change the root on chain, and also it make the data public. on this Astra, and there is an API too. So I'm going to just show you how it works and how it can be easy to create a new group for a developer. So when you want to generate a new group, you just create you just extend the group generator class, and you are going to put the generation frequency you want for the generation, for your generate function to be called and to create new groups. So, for instance, here we can see what is a group. So it has a name, a timestamp, some tags for easily matching and searching, and it has the data. So the data is the account identifier and the account value. The value will be can be associated then in the attestations value. So here it's an example that is not really interesting because you have just written 2 accounts and just that. So we had some data providers. So all is open source, so you can add yours if you want, and we will be really pleased for that. So we create a GraphQL provider, BigQuery provider that help to create a lot of data and with very selective way to do it, snapshot, etc. We also created some data operators to join, intersect, or map these groups. So here is an example where we want to create a ENS voters group with all the voters on snapshot that did a vote on ENS space. So you just instantiate your snapshot provider, and you just need to create all voters for a space. You can also create all voters for a particular proposal. So here the generation frequency is weekly. So that means this new group will be created each week, and those groups are going to be available for the attester. You can see the API, so it's really easy. In the second part, you have the attestations collection. So it's basically the link you are going to make between the group you have previously computed and the badge you want to be associated to these groups. So here, for instance, we are going for this attester. So it's the first attester we deploy, which is named Hydra S1 Simple Attester. We are going to take always the latest computed Ethereum Power Users group, and we are going to associate it with a badge, which is an NFT. So you have the metadata here, the name, description, and the image. So the available group, so the group which is here will be automatically transformed in a Merkle tree, and you will have an API for the front end also for the front end to call all the Merkle trees, the root, and stuff like that. The same for the badge. It will create the metadata JSON. So it looks like a metadata as OpenC and stuff like that. So it's an 1155 metadata. So with that, you can then let your users mint this badge, and it will appear directly on OpenC, and it will be easy to integrate with all different consumers that have the standard 1155. So OpenC here. You have also a guild. It's very easy to add a new gated channel just by looking at the here you have the token ID of the badge and the address of the construct. For snapshot, it's exactly the same. You have some strategies, and you can ask for your users to be eligible to have the attestations. And as the attestation is a ZK one, you don't know who is the user with this attestation. So the vote will be fully private. So here it's a vote to let self-evolve the group. Yes, and maybe you have some questions on the.
do have a question. So, is this available? Can we use and plug our apps on Sysmo yet, or when you?
Yeah, so we are going to be at the hackathon at the end of the week, so you can make a project on Sysmo. We will be really pleased for that, and you can also to our repositories. All is open source.
Hi. So I have a question about the update of the group. So let's say, for example, the Ethereum power user group.
Yeah.
Let's say that like you publish your attestor once, and then in the meanwhile, I don't know, you can update it weekly. This
Yeah.
group source. So who takes care of updating the state of this tree on chain? Is it the attestor itself, or is it Sysmo that does it automatically?
So the attester, as you have a contract which is called available roots registry that contains all the roots that are available for an attester. And yeah, when you deploy your attester, so you are the issuer of your attestations, you are also the admin, the owner of the available roots registry, and you can send a text to update the root on these contracts. So in this example, as we are the issuer and as we have deployed the infrastructure of the Sysmo data sources, we can we use a rule layer to automatically send the transaction and to update the roots.
Yes, perfect. Thank you.
Right now, it's a single source account, etc. Right? But
Yep.
but then on this, so it's sort of an assertion more than a question. Have you thought about making this sort of a roll up, or not so much a roll up, but a layer 2, in the sense that you'd open the putting of those roots, or is that because right now it's you putting those roots together, right? So there's a bit of a there's a bit of a trust. For example, you could imagine a contract that also outputs, like the proof also outputs all the accounts and does all the calls, like do you own this NFT, etc. Like, and verifies that the tree is actually true.
Yeah. So what we can do very easily to create a smart contract, which is an incremental Merkle tree, exactly as the one which is inside the Tornado cache. And you could directly construct or on Semaphore it's the same also. You could construct automatically your group on chain directly when you do some operations, and it will be fresh data, you know, and you won't have to wait for the new update as it's made in this attester.
Sorry, so I'm a little bit noob, but like, would that be possible? Because you need to do the Poseidon hashes. So can you do this on chain? No. Right.
Yeah, you can create a Merkle tree on chain, and recreate the root on chain and store it on a mapping. It exists and it's easily to do. So maybe there is other questions, or so maybe do you have some ideas for groups or stuff like that? Group of accounts. I see, Enrico, you posted a tweet about idea of groups of accounts or stuff like that. Okay.
Just a quick question, maybe something that I'm not sure about. That when you're generating attestations, it's 1155 the NFTs. When we are deploying, it's automatically on L1, or we can choose to deploy it on L2, for example.
So for now, it's on Polygon, and we are using a relayer, our own relayer, to relay transaction for better UX for the product, because it's very difficult for the user to switch between its source account, destination account, to have Matic and stuff like that. So we think with the L2 season, the price of the transaction will be cheaper and cheaper. So it will be on L2 majorly, but we will also deploy them in the mainnet. But now it's only an alpha. So our contracts and our circuits are not audited yet. So yeah, it's really an alpha, so it's not deployed in mainnet.
You have to update the Merkle root every time the group is updated currently? Is that right?
Yeah. Yes.
Is it, have you thought about, or is it even possible to use like something like ceramic where the root hash or like the hash could stay persistent, but you could go to like a data layer to retrieve the updated state?
So what you can do is verifying an update of a Merkle tree directly inside the snark, and you could update it like that. So more frequently, you could even let users update the Merkle tree directly by proving they well updated into the snark and updated the root. But we didn't develop that for yet, but maybe in the future we will see. But and for ceramic, I don't know how you are going to prove that you well computed the Merkle tree. So no, yeah, it's finished.
I missed the beginning as well, but like you asked for like groups. So are you, for example, working on proving NFT ownership? I guess so, right? Because you mentioned token gated, guild, and collabland, etc. Like
yeah. So for assets, for now we are more focused on historical data and what we can do with all this historical data. For assets, we have different ideas, but the fact is that you don't want it to be Sybil attackable. So what you want to do is, so what you can do is verify if you have, for instance, a punk during 1 week and update your tree every week. So it will be Sybil resistant. But there is different other ideas, as you could lock your punk in a smart contract. And with this locking, you could do a lot of different things. So, for instance, we want to see what developers are going to do, and we have our ideas, but we don't want to start for that. So we want to do it with the community.
right. Sorry, unless someone. I for a project I'm quite interested in these types of topics now, and so it's very nice that you guys are here and presenting this work. If I need, like, I'm assuming that at some points you need to write your own circuits as well. As is possible? Like, are your circuits public, and can you fork them and recontribute them, or how do you see this workflow?
Yeah, they are open source too. So you can see it, you can change it. So Hydra S1 is S for single source, because we just verify one source, but we could have a M1, which is multiple source accounts, and we could verify multiple stuff in different source accounts and aggregate these facts inside the circuit. So it will be better for privacy. So if you want to do it on the hackathon, you are welcome. So does someone read the docs.sysmo.io or have question about the doc or stuff like that? Okay, thank you.